All right, we're in a little 3-6 action here. We're doing 3-6 number 6. Okay, we got it over here on our Jamboard. This is a particularly difficult question, although you need to read it carefully. A couple things. Use a graphing utility or a computer algebra system. Okay, so that's going to be able to help us. And then round your answers to 3 decimal places. That means we don't have to write these as like 6 radical 3 over 4 or anything like that. We can round them, which means we can use our graphing utilities, namely Desmos graphing calculator, to help us with this. Okay, so first it wants us to find the intercepts. Why is it doing that? Pen, no, pen. And so to find the intercepts, let's put in 0 for x. If I put in a 0 for x, I get 0 times 0. Okay, so there you go. There's my x and y intercept. And then I have to solve this equation to see where my x-intercepts are. So how do we get 0 equals, well, either x equals 0 or tangent of x equals 0. Well, tangent of x is sine of x over cosine of x. And this fraction equals 0 wherever the sine of x equals 0. So then I think about, well, where on this interval is the sine 0? Well, that would be at 0, negative pi, and positive pi. Okay, and those are all within those intervals. So that shows you how they got, let's see. That's how they got negative pi comma 0, 0 comma 0, and pi comma 0 within those intervals. Now, let's sketch this. You could sketch it in your graphing calculator. I'm going to use my graphing calculator for something else a little later here in this video. So I'll put it in. And now you can see that, basically our intervals are from here to here. There's only going to be one relative minimum. Okay, only one place where the derivative is equal to 0. So let's go ahead and do that now. So let's mouse and clear screen. Okay, so let's take the derivative. In order to take the derivative, we're going to have to use the product rule. First, x times the derivative of the second. The derivative of tangent is secant squared plus second tangent of x times the derivative of the first, which is 1. Okay, so that's our derivative. So we can set this equal to 0. Well, I can tell you that alone is actually kind of hard to solve. I could show you how to solve it by hand, but I'm not going to on this video because I want to show you how to use your graphing calculator. We want to solve this thing. So x secant squared of x plus tangent of x. So x, back, mouse. Is this, okay. Now I need to look at my equation again. X times secant squared of x. Well, to do secant squared, you first got to type in 1 over cosine. And then you got to square it. So this right here is secant squared. So we got x secant squared of x plus tangent of x. I want to make sure I got the sign right. Checking to make sure we're in radians. We are. I'm going to graph it. That's a fun curve. Now, all we care about is where does this thing equal 0? Boom, it equals 0 at 0. It's the only time it equals 0 in our range. So that is how they came up with a relative minimum at 0, 0. And you can see that. Here's our relative minimum. Okay? All right, now let's see. What else do they want us to do? Clear? Come on, man. Clear. All right, so we got our intercepts. We got our relative min. There is no relative maximum. So now let's look at our points of inflection. And then our asymptotes. So our points of inflection are going to be where the second derivative equals 0. So if we go back and remember, our derivative was x secant squared plus tangent of x. So we'll start from there. Well, before I do the derivative, let me just tell you that you're going to want to think of that like this. Mathematicians are notoriously lazy. That's what makes them good at math. They don't like doing all the work. And they write secant of x quantity squared as secant squared of x. If you write it like this, you're more likely to get the second derivative right, because we're going to have to use the product rule again. First times the derivative of the second. Well, the derivative of the second is 2 times secant of x to the first times, okay, what's the derivative of secant? Secant tangent. So you got to do the derivative of what's inside. Most people miss that. All right, so that's just first times the derivative of the second plus second times the derivative of the first. This is just the derivative of this. So then I got to take the derivative of this as well, and the derivative of that, derivative of secant, or the derivative of tangent is secant squared. Okay. First times the derivative of the second plus second times the derivative of the first. Oh, hold on, plus second. This should be secant squared of x. Second was this. Okay, good. I'm glad I caught that. So to summarize, you get g double prime of x. The second derivative is x times 2 times secant squared of x tangent of x plus secant squared plus secant squared, so that's 2 secant squared x. We have to find out where that thing equals 0 to find our inflection points. So now we'll go back to this, clear it. Here we go again. Back, mouse, save mouse, pen. I don't know what is going on. Here we go. All right. So 2x secant squared of x tangent of x on our calculator. 2x and then alpha y equals enter secant squared. All right. All right. 1 over cosine of x squared, and then times tangent of x, and then plus 2 secant squared of x. So take a good look at that. This equation that I just typed in is this equation right here. And I'm telling you, I know that took a while, but this is going to be the fastest way to solve this thing for 0 because it's difficult. Now, we only want to solve it for 0 in between these two bounds right here. Okay, so I need to find this answer, and I have full faith that that's the same one. So I'm going to go calculate zeros. You remember this from Algebra 2? And I got to hold it down for a little while and look for it. Here it comes. Here it comes. Go to the left of the answer, hit enter. Go to the right of the answer, hit enter. And what did it do? Use this algorithm and found that the answer for our inflection point is negative 2.798. Now, how do I find the 1.101? What I could do if I wanted was um, go to my table settings. Remember to change it to ask. Okay. And go to my table and put in the negative, what was that number? Negative 2.798. And then it'll pop out the output. If you go over here, it'll give you a closer. Uh-oh. Hold on a second. Oh, I made a very common mistake. In this is not my original function. My original function was in Desmos. So I go to negative 2.98 and notice if I can find it. Look, there it is. Almost there. 798. Anyway, that's how you just plug this into your original function and that'll be your output. Okay. So finally, where are the asymptotes? Well, again, to find those, I need to go back to my original equation. And I need to find out, well, where is the original equation undefined? Well, it comes down to what's the tangent of x? It's x times sine of x over cosine of x. Well, anywhere the cosine of x is 0, we're going to have a vertical asymptote. Where does that exist? That exists up here and down here. So that's pi over 2, negative pi over 2. And then it would happen again at 5 pi over 2, but I think 5 pi over 2 is not in our interval. And so that is how they come up with the asymptotes. Oh, but 3 pi over 2, let's see, 3 pi over 2. 3 pi. Oh, yeah, that would also be on it. It's also saying that it hits it at the extremes. You'll see that there's vertical asymptotes here. 3 pi over 2, pi over 2, pi over 2, 3 pi over 2. All right, I hope this helps. It's a tough problem. Needed to use a little assistance from some graphing tools. Boom.